sample proportion, the notation for the population would be like the population proportion. The population proportion is P. The notation for a sample proportion, do we remember what it would be? Yeah. What? Oh. The shape condition. So then we talked, at first I started off with like RIN, like randomness, independence, and normality. But then I kind of realized maybe I should be doing shape, center, spread. But you can if you want, like shape is normal, that's your R. Center is your R. Shape is N, center is R, and spread is I. But shape, center, spread probably puts it more into like what you guys are used to. And when we had a sample proportion, the shape of that was approximately normal as long as what? Do you remember? So that's the independence rule. NP and NQ have to be greater than or equal to 10. Does anybody remember what that's called? See how nice it is to have all this space to like freely. The center, or the R, what we call R, we need randomness. Means unbiased. I kind of want an entire new sheet of paper now because that is slide. The spread was independence. And this could look two ways depending on if you are taking a sample or if you're not taking a sample. If you are taking a sample, what Angie was starting to say, your sample needs to be less than or equal to 10% of the population. And then the second part would be, sometimes you can't show that. It'll be like, you're taking a multiple choice question with 50 questions. You're not sampling, but it's still like, produces sample data. So the other way would you would just say each blank is independent. So like each question is independent. Or each spin of the wheel is independent or something like that. And then the mean of the sampling distribution, so that's the mean of P hat. So I know we're dealing with proportions, but when we put the data on a sampling distribution graph, it's going to have a mean. So even though it's proportions, we still have a mean. So the mean of the sampling distribution for proportion is P. So that's just saying these two are the same. That if I do my sample unbiased, my sample in theory will have the same information as the population. So if 80% of you guys think we should have snow day today, if I of the school, and I randomly take 30 people, in theory 80% of them would also say that if I do it unbiased. Now it's not going to happen every time, like every sample is going to be a little different because of sampling variability, good. But like that's the idea. The standard deviation of your sampling distribution is the square root of PQ over M. So that was the first section we did. Question on that top row anywhere? It's probably a good refresher because it's been a week since we've done anything. See what? See that? there's supposed to be a hat down here, but not here. Zoom in. Okay, second row. Difference in sample proportions. That's P1 minus P2. So that's like we're comparing two things. The proportion of juniors that have a job versus the proportion of seniors that have a job. If we're dealing with the population, there's no hat. If we're dealing with the sample, you would just put a hat on both. The shape condition is the same, it just gets like a little bit longer. So it's like N1 P1 is greater than or equal to 10. N1 Q1 is greater than or equal to 10. N2 P2 is greater than or equal to 10. N2 Q2 greater than or equal to 10. That is still the law of large numbers. Law of large numbers. It's still approximately normal. So it's the same as the box above, you're just doing it for like two proportions instead of one. The next one's the same, so randomness means unbiased. And then the spread condition is the same, it's just for both samples. So you could just write like same as above for both. Depends how much stuff you want to try to squeeze into this little space here. So I would go like N1 is less than or equal to 0.1 times population 1. N2 is less than 10% of population 2. Or blank independent in both samples. Okay, go ahead. So then the mean of the sampling distribution, so the mean of sampling distribution P1 hat minus P2 hat is P1 minus P2. Again, the idea is our samples should, in theory, come up with the same data as the population, as long as we're doing it in an unbiased, fair way. And then the standard deviation of P1 hat minus P2 hat is the square root of B1 Q1 over N1 plus P2 Q2 N2 over N. So hopefully that looks like somewhat familiar. It's been like a week since we did it, but okay. So I'm going to do sample mean now, which is new. So I'm kind of like teaching it and filling it out the chart at the same time. Am I good to move past this? Is everyone still ready? Okay. Sample mean. So if I'm dealing with the population, the mean is mu. If I'm dealing with the sample, the mean is x bar. We still want to do a check a condition to see if the shape is normal, but we can't use p because we're not going to have p. Sample mean is like the average of something. Like what's the average age? What's the average shoe size? I can't say like the proportion of shoe sizes. Like, that doesn't make sense. So we're not going to have a p. So there's two ways that the shape can be approximately normal. So approximately normal if it can either be that n is greater than or equal to 30, your sample is greater than or equal to 30. That's called the central limit theorem. that more down the road. Or if it tells you the population is normal. Or if you are told normal population. So for the center, we still randomness means unbiased. So I want to know the average height of all the students in the school, and I fairly randomly take a sample of 30 of you. Not going to happen every time, but on average, I would expect the average of my sample to be the same as the average of the big population if I'm doing it fairly unbiased. So randomness still means unbiased. This independence is the exact same thing as it was before for the one sample one. So n is less than or equal to 10% of the population. Or each whatever is independent. The mean of the sampling distribution, so what that says, what I'm saying is the mean of the sampling distribution. If I have done it fairly, randomly, the mean of my sampling distribution will be the same as the mean of the population. What's the mean of the population? What's the notation for the mean of the population? And then the standard deviation for the sampling distribution is the standard deviation of the population. So notice like this has an X bar, that means the sample. This does not have an X bar. That means like the population standard deviation. Divided by the square root of it. So we're going to start an example or two of this right now. We'll keep going Monday. Eventually we'll fill out this fourth one. It'll be stated. You'll have, yeah, that would be given to you. Alright, so I'm going to ask you to get out your notes. Unless, do I need to like show anything up here? Again? Everybody okay with that? So get out your note packet. What is what? Little n? Sample size.
Okay.
How many of those do you want? You're gonna make like a perfect one.
Yeah, well, okay. I just don't like looking
On poster board or something?
No. I'm not that over the top. I just would rewrite it one time. Also, it helps me remember.
Totally. No, I'm not. When I studied in college, I would just write things over and over again. So like, I didn't have to look back at whatever it was. So I'm gonna do that one. I don't know if that's got to be in like notes 4. Right? That's in notes 4.
Yeah.
So the template up here is kind of what we've gone through before. The state plan to. I'm not worried about conclude yet. So if the questions on this homework are asking you to conclude, I'm not worried about that yet. We're certainly going to do that. It's a huge thing. It's just not something we've really gone through yet. I'm not quite sure why it's in here, but okay. So the first thing I'm going to do is state or intro. And I would say, so before, we said like P equals the true population proportion of whatever. Well, Now it's means, but I know it's means because they're giving me, it says mean, it's got that mu in it, that means mean. So I'm going to say mu is the true population mean of whatever. So put your context there. And then she says plan. I would say conditions, either way. And then this is what your like gigantic sheet of paper can help with. You can't use it on the test, but it can help you kind of like sink in your brain. So I'm gonna do shape center. I don't know. Should I do the RIN order I did before, or just go like shape center spread in that order, or do you care? Shape center spread, shape center spread. Okay. So the shape condition, it's going to be approximately normal because, and I'm going to say why. So if I read through the problem, we took a sample of 10. There's two ways your shape is normal. One is you took a large enough sample, which is 30 or more. You didn't. The other is it tells you the population is normal. So if you look at the question, it says, suppose the heights of young women are normally distributed. So they're telling you the population is normal. So the shape of our sampling distribution will be approximately normal since the population is normal. So for the center, we want what? What am I looking for? I want randomness. Where do I see in there that it says randomness? SRS. SRS. So the mean of X bar is the same as the mean of the population, which is 64.5. And then spread. So I do have, so I'm looking for independence. Is 10 less than or equal to 10% of all young women? Someone say no. Is 10 less than 10%? Is 10 less than 10% of all young women in history, world, ever, always? Eternity. Yes. That means the standard deviation of our sampling distribution is the standard deviation of the population divided by the square root of n. The standard deviation of the population is 2.5. I took a sample of 10. I'm just plugging my numbers into those spots and I can get a sample standard deviation. Which is 0.79. And then if I were to like summarize that, what we just found is that my sampling distribution looks like that. It's approximately normal. We went through and showed that that is true because we looked at the shape. So this is like shape, center, spread, basically. Shape is normal, center is the mean, spread is the standard deviation. And now I can answer like any question that you ask. You know, like what's the probability it's greater than 68? What's the probability it's less than 62? Now it's just normal CDF. So what they're asking is greater than 66.5. So they're saying what's the probability X is greater than 66.5. And that's going to be normal CDF greater than 66.5. 66.5, comma 99999. Tell the calculator the mean, which is 64.5. And tell the calculator the standard deviation, which is 0.79. And then, I don't currently have batteries in my calculator, so I'm going to need someone else to do it. Or, like, the answer's not even my main concern. But we probably should have. Should be less than half. Have I got a number yet? We have confirmation of that? 0.0057? Yes? Okay, thank you. Is that part okay? Like, once I give you that, you're okay. You can find the answer, right? I just don't want to find batteries. Questions on that one? Do you need it still? Well, I can put it back in a second. I'm just looking at like, what I want you to do. Yeah, do the next one. The flaws per square yard and a type of carpet. I'll put it back. My grades aren't due till like the end of next week, so that's fine. As soon as you can, but the end of next week at the latest. Sometimes you have to make assumptions. Like it does not say this one's random. So you have to put assume randomness. I didn't say the population distribution. I said since I was great. So there's sampling distribution. That's still
Oh.
the population shape. Remember the bar? I got over here what the shape was on top, and I take enough samples. So the population. You guys know that second semester does start Monday. I think you mostly probably have year one classes. If you have semester classes, they do switch Monday. This is the end of our time together. That's a weird question.
I don't know. See how he avoided that question.
I got no question. I give it this to a person more than this. Seems fair. Do you like me?
Yeah.
I couldn't live with myself.
How much did that shirt cost?
Well, you asked me when you want me to say it.
30 years of blood, sweat, and tears. 30 bucks. Oh no, it's Mr. Shin. Like, I haven't talked to him about it, but someone told me he like legit thinks Michigan does side stealing some stuff, so I bought it. I might just buy like just wear it like every day. UNC. So I might just wear Michigan shirt.
Bro, I don't understand how you think
That makes sense.
go to like Michigan State and like not care about Michigan at all.
Michigan State is Michigan State.
I know, but like State. Michigan's closer to the state. Okay, like if State was in the national title,
I hate the Michigan State.
I mean, basketball was good. It was crack.
Okay. Am I good? Are you guys good?
Every basketball song.
So I just like want to make sure you understand what we're doing or why. Same process as the last couple we did. It's just like now we're working with means instead of proportions. But you're gonna go ahead and like state the thing. I think in the last version of this, I also wrote down like what we know. So like n equals 200, mean equals 1.6, standard deviation equals 1.2. If you want to, like, you don't get or lose points for that, but it's just like, okay, that's summarizing what we have. These are my conditions, going through all those, and then doing my work and calculating. And I got, this is like 0.0000126. At that point, you can basically say it's approximately. Questions on that one anyway? I got something different here. Why'd you put this? What does this mean? Okay. Go to the next one and be careful. So first of all, I don't care about part D. But be careful on part A. Because part A is not what we've been doing. It's not what we did today. You could have done part A in chapter 2. This is not me taking a sample of things. This is not like I took a sample of 30, what's the probability of this? This is one probability. So you don't need to do any of the stuff that we have just done, and you just type in normal CDF, blah, 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 mean standard deviation. This is not a sample. Because it's just a single randomly selected can. So you don't have to do anything except the normal CDF stuff. The only thing that would change, let's talk through like why that works. The mean is the same no matter what. The standard deviation, we divide by the square root of the sample size. Well, if the sample size is 1, what are we going to divide by? 1 change my original standard deviation. It's not. So the original standard deviation goes here, or you can put like divided by the square root of 1 if you want. Maybe not put in the wrong spot. And then part B and C are what we're learning today. It is in this specific case. I would just always put negative 999 because sometimes it's not. So just to get that habit. But like 0 is so far away from 11.9. If your standard deviation is that small, it's not going to matter. But sometimes it will. Did I not say that? That's legit. I put the same. That's my first. Yeah, that was sloppy. For part A. So because it's not from a sample, you don't need to worry about like this. Your job is put standard deviations. Because it's a sample, my first thought is okay, I'm going to do this observation standard deviation divided by the square root of the sample size. Well, what's the sample size? So you divide it by 1. So it just stays the same. It doesn't matter because we're not taking a sample. So you look at it two ways. We're not taking a sample, so I don't need to do any of this sample graph. I'm going to go back to chapter 2 and just type it in. Or you can be like, we are taking a sample. It's just a sample of 1. So my standard deviation is going to divide by the square root of 1, which doesn't change. It's also like, it's been a week since you did it. I'm trying to review 2 things, show you a new thing. Like, it's not. Okay. A lot of time. So let me talk through these and just kind of like review what's going on with it. So part A. Part A is before we start taking samples. It would just be like, we have this data. I'm going to take one can, find the probability it's bigger than or less than whatever. So there was no sample data to worry about. There's none of this new standard deviation to calculate. It's just like the old version. Or you can, because the only thing that changes if we're taking a sample is your standard deviation gets divided by the square root of n. So if you look at this as a sample of 1, it's the same, because dividing by the square root of 1 won't change. Part B, I kind of worked my way to this. How do I know the shape is approximately normal? Because they didn't really make me say it. Because we got greater than or equal to 30, right? We have a sample size of 50. How do I know that the mean of the sample distribution will be 12? That's the same as the original. How do I know that's the case? Because we took a random sample, so that justifies that. And the standard deviation, I'm allowed to do as long as I know things are independent. How do I know things are independent? Again, they didn't ask you, I'm just like spitballing here. No, we can do more than this. Yes. So I took 50 soft drink cans. I'm assuming that's less than 10% of like all the pop cans that they make. And then in part B or part C, I'm just doing my calculation. Like once I have that, they're saying, okay, now what's the probability we're 11.9 or less, and it's much smaller. So this is, yeah, I don't want to get into that yet. Questions on like the answers there? Yeah. Depends like what you do where, how much. That's fine. Yeah. Other questions? Did I round it too much? So 0.0565. So I should have done that. Yeah. All right. So try 1 and 2 here on the homework. But be careful because they're not both what we just did. You have this. One of them is what we just did, and one of them is one of the other things on here that we did last week or half ago or whatever. And it is just asking you to find the probability. It's not asking you to justify the shape centers for any of that. It's just saying find the probability. So you don't have to write all that stuff out. Giant sample size of number 2.
Pretty specific number 2.
Yes, yes it is. those are the two answers I got. Is that right? Hang on to your mega sheet. I think that's going to be helpful for you. For a sample. So I'll take it as a so like you can just work with this.
You like
It
hops?
doesn't tell you.
I'm trying to do that.
So you could use just everything.
So, just,
Or
I don't have, I'll probably have, so,
so in this one, you could have just has a magic or you could
and then you know what it turned into, relax, so we all know. That's like, my grade, it's like 2 GPA.
but that's we're gonna practice.
Just like, I'll find like,
One of the issues becomes like
I'll find like 4.
it's sort of hard to tell sometimes am I taking a sample or not. And we will definitely practice. You got the